So last video for the day one assignment, the last two problems. These ones I'm going to take a slightly different approach, and I'm going to work both sides of the equation. Now, what I mean when I say working both sides of the equation, it's not like your regular algebra, 2x equals 5y plus 3, where you're adding and subtracting and multiplying and dividing on both sides. You can't do that with this. You can only work one side at a time, but you can work both sides independently. So what I mean is, what I can't do is start by taking this sine squared and adding it to both sides. That is not allowed. There are cases where that could end up with the same answer and it would make sense, but there's a lot of cases where it screws things up in the end. So it's just something that we just say it's not even allowed. All right, so looking at this, I've got sine and tangent on both sides. One of them is a difference. One of them is a product. I'm going to focus mostly on the difference because, again, I think it's easier to work on the more complicated side and make it simpler. And if it's two terms, making these into fractions and combining the fractions so it's one term is going to be easier to get it to look like this than to go the other way to try to split this apart. But what I'm going to do here, because it's sine and tangent, I'm going to rewrite, and it's on both sides, I'm going to rewrite both sides in their sine cosine forms. So sine squared, and then this would be sine squared over cosine squared. And on this side, it's sine squared over cosine squared minus sine squared. And because this is a fraction, I'm just going to say sine squared over 1. Okay, sometimes this can really help get a better idea of what you're shooting for on this side. Is to just break down the other side a little bit and give you one less step to do on this side, right? Give you a little bit of guidance at some point of how to get it to look like this. Okay, so looking at this, I've got two denominators. I'm going to want to do cosine squared over cosine squared to make a common denominator. So on this side, I'm now going to have sine squared minus sine squared cosine squared all over cosine squared. One big fraction. Sine is with both terms, so another case where we're going to factor it. So it's sine squared and 1 minus cosine squared all over cosine squared. And now, that 1 minus cosine squared, remember that's the same as sine squared. So this is sine squared all over cosine squared, and look at that, sine squared over cosine squared, sine squared over cosine squared. I don't even need to combine these and make it sine to the 4th. That's one step that I don't really need to do. Both sides match, so now I'm good. All right, this one, I'm going to do something similar with it. I'm going to take this side and convert it to its sine cosine form, and then I'm going to work on this in a slightly different way. So there's a cosine here, and then everything else is kind of in the reciprocal forms. So maybe just getting some of the stuff into sine and cosine is going to help sort of guide me on this. All right, on this side, 1 plus cosecant. Secant is 1 over cosine. And so the reason that I did that is I recognized I can take that that denominator and make it into its reciprocal and then flip it to the top. And then this is no longer a fraction. And I think that might make things a little more simple. So now it's, if I do keep, change, flip here, right, I would flip that and multiply it on the top. So I'm multiplying the numerator by cosine over 1, or just cosine. Now if I distribute that in, cosine plus cosine cosecant. I've got cosine and cosecant on this side, cosine and sine on this side. What happens if I change that cosecant to 1 over sine? I get cosine plus cosine over sine, which is exactly what I have here. Now you could have changed this to 1 over sine at this step. I didn't, just because I knew it would be a little messy to have fractions on top and fractions on bottom, but you could have done the same thing and it would have